Max Wayne the Husky, what am I watching? You're watching the very start of my stream, so I'll explain what we're doing in a short moment's time once more people have jumped on the stream. Just waiting for the stream to pick up a little bit, and then we'll crack on with this. Now, this is a, if you're new to the channel, this is a amplifier repair live stream. So what we're doing is we're looking at amplifiers that are absolutely fucked, and we are seeing why they're fucked, and seeing how to make them unfucked. So replacing bits on there, I show you what to replace, I show you where to look for issues, what the most common problems are with these amplifiers, how to not end up in a smoky bad situation, driver, SMD soldering and things like that, and how to check for different waveforms on the scope, and yeah, all kinds of really interesting, fun, technical shit that we look at on this channel. So yeah, if you're interested, buddy, stick around a couple of minutes time. I'll get started off with this repair. This is a Power Acoustics. This is a Power Acoustics badass motherfucker, which is the BAMF series, which I only found out the other day that that's what it stands for. Badass motherfucker. So this is the amplifier. This is the front of the case. Whoop. My camera doesn't like that shiny surface. There we go. Power Acoustic badass motherfucker. So yeah, we started this repair yesterday. We got part way through the repair, we fixed the power supply, and we're just looking at the output section. Yeah, I got a notification and it said Power Acoustic in it, and I immediately clicked on it. Haha, fair enough. Yeah, Power Acoustic, this amplifier is actually one of their newer amplifiers, and I don't rate them particularly highly. They're not the best amplifiers Power Acoustics ever made. It's not as good as their old stuff. And it claims to do 5,500 watts on the front. So we're gonna fix this and bench test it and see how much power it actually does. I reckon yesterday's guesses were around about 1,800 watts to 2,000 watts RMS at 1 ohm on the bench. First of all, I'm gonna have a quick vape. So yesterday we were looking at why the output section here didn't have any Class D switching. So yesterday we had all these FETs in place. So I've removed all of these FETs. So they're all to the side now. And we're going to see why this thing doesn't have any Class D switching on the outputs. The amplifier comes on. We have all the main rail voltages that we need for this amplifier to work. But it wasn't switching. It was just nothing. No Class D switching whatsoever. And I reckon it's probably because of this chip here, which is the IR International Rectifier Class D half bridge drive chip. Was it? No, it might be a full bridge class. Might be a full bridge drive chip. Actually, I think there's full bridge. Was it a half bridge? I can't remember. It's up from Houston, Texas. I usually catch these at night. I'm taking lunch and at work right now. Nice, awesome. That's pretty cool. So, Walled Sonic, what are you eating for lunch, my friend? What's your lunch consisting of? And yes, Chris, the audio problem is fixed. I don't know how it got fixed. It just got fixed overnight, randomly. I don't know how. But yeah, the audio seems to work great today. Salad and sushi from the supermarket. Good choice. I do like a bit of sushi myself. The only thing that I've eaten today myself is some toast with toast and Marmite and Edam cheese. I love a bit of Marmite. Who loves a bit of Marmite and who thinks it's jank? Okay, let's get started on this output section then. Let's get started on this output section. Okay, what's up guys? Power Acoustics Badass Motherfucker 5.5k with dead output section and dead power supply section. On the last live stream we fixed the power supply section. We didn't need to touch the drivers. The driver ICs are in the middle of this board here. There are some surface mount drivers. We didn't need to touch those. They were all good. All we needed to do was just fit some new power supply MOSFETs. So that's what we've done. Output section wasn't switching. We had no Class D switch on the outputs. So we're going to find out why. ¿Por qué? ¿Por qué no tienes? I had a hot pocket. What the hell is a hot pocket? Let me know what the hell a hot pocket is. Would you mind mentioning what you use in your high watt vape? Well, yeah, it's like my mod actually is crap, so I just decided to laugh off the mod and hook it up to my Dell server power supplies. So the tank is a RDA. And it is a Drugger RDA. I can't remember what the coils are wired to. It's something stupidly low. Flat wound coil in there. Can't remember what the metal is because I haven't built it for a while now. I replace the cotton quite often. But I have some custard cream biscuit and some Wrigley's and some white chocolate custard. All sorts of different flavours. And it's getting 12 volts and it has 350 amps. 350 amps behind it. So it's about 4,200 watts of power behind my Vapor Ruby. Rowan, one of the haters. Who is a hater? Who is a hater? Okay, so to find out why this thing isn't giving me Class D switching, what we're going to do is we're going to turn our attention to my signal generator here, my function generator. We're going to throw some sort of 45 hertz tones through this board with the output MOSFETs out of the board, and by doing that we should see where the switching frequency gets lost along the board. So the switching frequency is all over in this side of the board. Let's see if I can zoom in here a little bit without the quality going down too much. So yeah, this section here is the drive circuit for the output section. So we have a TL072C, but in this case they've used something else. They've used a bigger package version, which is a 4580, but you can use a TL027C there. And we've also got an LM311 chip, which we can also use an LM211 if we want to. So these two are to do with the generation of the Class C switching wave and possibly the protection circuit. And then we have another chip here, which I haven't seen a great deal amount of before. This chip here, this will be generating the Class D switch wave based on the audio input. Then we have the main driver here. This is the main driver that drives the MOSFETs. It's just being used as a pass-through, as a driver, as a buffer, essentially. And this is an IR2113, I think it is. I can remember from yesterday. Yeah, 2113S. IR2113S, which is a high voltage chip. I would have thought that they would have used a 2010S, which I have loads of in here. In my drawer, I've got loads of these driver chips, which are used on Banda and Tar amps. Some Brazilian amplifiers use them. Also, I think Alpine MRP amplifiers use these drivers, and the 2010S are higher current and slightly lower voltage, but this amplifier is not going to be getting anywhere near the high voltage that the 2113 is capable of. So why have they put a 2113 in there? I don't know. Oh, Marmite hater, lol. Ned Frost, how's it going? That is a very convenient name because it is freezing and frosty outside in the UK. It's absolutely freezing. It's like... Max says I have to get ready for work. See you later. Thanks for tuning in briefly, buddy. Thank you for tuning in briefly. So, we're going to force 45 hertz through this amplifier and see what happens, where all the drive waves are and where it loses it. So we're going to put our RCAs in here. RCA's in here. Going to make sure the gain is turned down a little bit because we don't want to send this into clipping, you know, without the FETs in. So we're going to turn the gain down. Da da da. Subsonic, we're going to turn that down. Bass EQ all the way down. Wow, the bass EQ was all the way up. That's never good. Low pass we're going to turn up because we don't, you know, we might as well turn that up. Okie dokie. So let's plug her in and see where the 40 Hz ends up on this board. Kind of chilly in Norway. Yeah, I bet it is. Norway sounds, I think from the pictures I've seen of Norway, it's pretty cold there. Right. Power. Oscilloscope probe. Oscilloscope probe plus ground. Yep. Oscilloscope probe, and let's see. Let's probe the power supply section, and let's just make sure the power supply section still works from yesterday. Let's get up, up, up. There we go. Power supply section looking good. And if we probe the outputs here, we can see that on the outputs we have minus 51 volts and plus 52 volts. So a little bit of offset there, but that's not a problem. So these are our output voltage rails. These are our voltage rails that the audio is going to be swinging between. Okay. So with the FETs out of the board, we should see a low side drive wave that should run along this rail. So we should see a square wave that runs along that rail, but there's not. There's no square wave running along that rail. I'm going to turn my scope up a little bit with the time divide so I can see my 45 Hz that I'm shoving into this board. Ah, hang on a minute. We do have a square wave there. Okay. So this is what I wanted to see. So when we force 45 Hz into the amplifier, we do indeed have the low side drive wave, which is present. Interesting. So that hints to us that the drive circuit might be okay, although we have nothing going on here on the high side drive. Now this is a circuit which this specific drive circuit is not one that I've had a great deal of experience with, using this driver IC and the setup that it's got here. It's kind of similar to a Brazilian drive circuit, but a lot more simple. Now this is what is going on with the high side drive. So the low side and the high side is driven. So the high side drive looks kind of like this. A high side drive doesn't always show a nice wave on the scope when you without the FETs in. It doesn't always show a thing on the scope without the FETs in, so that could be fine, but that could also mean that the driver is screwed. Interesting. Okay, so before we go any further, what I'm going to do is I'm going to check these FETs that we took off of the board yesterday on the transistor tester to see if any of them were dead. If some of them were dead, then that obviously would have prevented the amplifier from coming on. So first of all, I'm going to filter out any of them that are making a dead short circuit, because there's no point testing any that are showing a dead short circuit on the multimeter. So get a multimeter here, and that's one with a dead short. So what I'm going to do with these ones, put them over here. That's a dead short. That's a dead short. That's a dead short. Okay, that one's not. So we can test that. That was one of the ones that came out of the amp. Dead short. That one's not short. Not short. Not short. Not short. Short. Not short. And last one, not short. Okay, let's test the not shorts, because these are the ones that I pulled out of the amplifier last night, just before the stream decided to screw up and we lost all our audio, which was very strange. Pro Latvian says, thanks for blocking me. Who blocked you? So you figured out the stream? No idea. No idea what was going on with the stream. Not a single clue what was going on with the stream. I just turned it all off last night and I came back this morning and it works. So not got a clue what that was all about. Okay, so we're looking for around 4 volts of VT and around 7.7 volts of gate capacitance. Sorry, 7.7 nanofarads of gate capacitance. So these all look pretty much okay. Yep, 4.1 volts of VT, 7.8 volts of gate capacitance on all of these, so interesting. So the low side drive does work, but the high side drive doesn't. The VT on this one is 3.6, holy crap. So the VT is the voltage which these FETs need on the gates to turn on. And we've got a few different batches here that were loaded up into the amplifier, and the VT is 0.4 volts different from one another, from batch to batch, which is very bad. What it means is, it means that some of these FETs will turn on 0.4 volts sooner than the others, and when that and when that happens, the ones that are turning on first will try and power the ones that are currently turned off backwards, and they'll start to heat up, and it will draw more current than it needs to. Okay, okie dokie. So none of those are actually dead, so we weren't getting any drive with the FETs in place. Interesting. What I'm going to do is I'm going to load this amplifier up with a slightly different FET. Hi Speaker Freako 2, how's it going, buddy? Let's have a look at what these original FETs actually are. So these are IRFP 260N. And let's have a look at the datasheet for these to see what they are. I think these are a 200, yes, these are 200 volt FET, and these are of an ID of 50 amps and 300 watts power dissipation. Okay. Now let's see if we have anything that we can use as a substitute, just because we haven't got a batch here that are all matching, which is not ideal. So I've got some spare 69N25 FETs here. So I'm going to see what these are, and from memory these are 69 amp and they're 250 volts. They will start getting super hot if off by that much, says the third era. Yeah man, for sure. Not good at all. Not ideal. Come on. Why is that not loading? There we go. Okay, so I've got some spare ones here which are 250 volts, 69 amp, and the power dissipation of these ones is 480, so these are loads better. They are loads better. These are loads better. So what I'm going to do is put some of these in, and then we're going to still drive 45 hertz into the amplifier. We're going to drive 45 hertz into the amplifier whilst it's powered up and see if that changes anything. So I'm only going to fit one FET per bank, so we need to check where the banks are. So if we probe here the gate resistors, and what we can do is we can see which banks are in parallel by which of these gate resistors are in parallel. So we have this is a bank here, this pair. So yeah, this pair is one parallel bank, as is this one. Okay, so we only have 3 low side and 3 high side. So I only need 2 FETs in this amplifier for the thing to come on and start working. Great. Muy bien. Estupendo. I'm just going to very temporarily put these on the pads, put these FETs on the pads. And I'm just going to have to mute you guys for one brief moment while I take a call. Okay, thank you very much for that. So yeah, that's 1 per bank. Ra-ta-ta, 1 per bank. So this wasn't coming on and wasn't providing us with our Class D switch before, with the old FETs in place. So let's try it again now. Now that we fitted 2 of these in place. Okay, so we have all the way, we have our correct rails, we have our negative rail, and we have our positive rail up here. Now, this usually, Class D amplifiers usually start switching when you have the FETs in place like that. I wonder whether this amplifier has some kind of strange circuit where it only applies Class D switch when it hears an audio signal. So we're going to apply our 40 Hz into the amplifier, or 45 Hz into the amplifier, and see whether the thing starts to come to life. If not, then we have a damaged high side drive. So let's start the amplifier up again. There's our low voltage rail, and let's hit 40 Hz. Ah, no, it's not happy. You see that? That is the that's the amplifier attempting to work, but not working at all. Let's see that again in a bigger view. So I'm going to probe the high side this time. So it's the high side that seems to be not working. Okay. See that? That's the high side drive. That's not happy at all, is it? That is not happy at all. So the high side drive seems to have been killed. So the first thing that I'm going to do then now is I'm going to remove the first thing in the chain of this amplifier that drives these outputs. And the first thing in the line of fire is this IR2113S chip, and we're going to replace that with an IR2010 chip, which is a slightly better chip. And here we have one of those chips. So we're going to get our hot air gun out and remove that IC. What kind of capacitors are they using? They are using 100 volt 1800 microfarad by a brand called Success. Success. I hope that we get a success with this amplifier. That would be lovely. Okay, where's my tweezers? Here they are. Start preheating the board around this area a little bit. They use those Success in Rockville amps sometimes too. So all of the Rockford rip-offs then, which this amplifier clearly is a Rockford rip-off. It's important to preheat the board like this, because if you just dump the big heat in one section, then you can cause the board to popcorn, where the board like bubbles and lifts up from the middle layer. Rockville, yeah. That reminds me. Rockville actually reminds me like of those amplifiers you see that are a rip-off of Alpine. I think it's called Pine. It's like a load of slashes and then Pine. Do you know there's also been rip-offs of Sony Explod woofers as well? Like, why would you even want to rip that woofer off? I mean, yeah, it's a good budget woofer, but it's like literally one of the cheapest woofers around. Why would you want to rip off a Sony Explod? If you're going to rip off something, why not rip off something that's half decent, you know? Welcome to Hydraulic Press channel. I love that guy's accent. I love that guy's accent. Oh, it got crushed. Ken Ford. Who are our favourite YouTube technicians? Lewis Rossman. Finglish is great. I'm going to turn my temperature up a little bit. I'm at 370 Celsius, but it's not coming off too easy, so I'm going to bump it up to about 400. Yeah, the Sony are fantastic woofers, but like they're still like an entry level woofer. So I'm not ripping into the Sony Explodes at all. I think they're amazing woofers. They're very well built and they take a shit ton of abuse. Really nice voice coils in them as well. But yeah, no, I'm just saying if like somebody was gonna rip off something, it's like they're ripping off a budget line rather than like maybe like a top end line. My Sony that I got yesterday till I can replace my tower amps for some reason has no audio. Oh, interesting. Wonder why that is. Jason, is that one of the grey hexagonal amplifiers? Sony Explode. Oh, is it? No, it's not a hexagonal, is it? It's a pentagonal. It's 5-sided. Wow, there must be some serious thermal mass around here. This chip is not wanting to budge. Are you working off a schematic for the board, or going past trial and error, knowing where to look for failures? The latter, my friend. The latter. I never use a schematic when I'm working on these car amplifiers because it's very simple circuitry most of the time. You can basically tell where to look, and you can work out what's dead by throwing power at it and seeing what the waves look like. There, finally, about damn time as well. Right. So let's run some new solder balls on those pads. Let's reball by putting it in the microwave. Go, fresh new solder pads on there, lovely jubbly. And now we need a new IC. Ah, the markings on this board are not helpful. The markings on this board are not helpful. I'm going to show you something interesting and fun that you can do with these chips. So now that we've got this chip off the board, so this is our replacement, this is our IRS 2010, okay? But before I put it on, I'm going to power the board up again, and I'm going to probe some things around around the area. I'm going to probe some of the pads of this this driver IC. And the reason I'm going to probe some of these pads on the driver IC is I want to see whether the high side drive signal is actually being sent there in the first place. Because if the high side drive isn't being sent there in the first place, then we're going to need to replace some of the circuit behind it as well. Okay. So you can see there's some markings on the board here to tell us where things go, where the chip goes. So unfortunately this doesn't have a little dip, because I took the chip off, the old one, without checking its orientation, and usually the board tells you the orientation that it's meant to be. This board doesn't tell you the orientation, but it does tell you which pins go where. So I can just pull up the schematic for this the data sheet for this chip and work it out from that. Here we go. So pin 1, where the dot is next to low. So that goes this way round then. So now I've worked out the orientation for the chip. Great. Great. So now I'm going to actually probe the low side input and the high side input. So we need H in, logic input for high side gate driver outputs. There we go. And L in. So we want to probe H in and L in. Make sure that we have waves on both of those. I think we should probably have waves on both of those. I'm just going to apply some alcohol first to clean that up a little bit. Make it a bit easier for us. H and L. There we go. So we want to probe H and L and see what's on the scope at H and L. But we need our 45 hertz going in order to do that. So let's turn the amp back on. Amplifier's back on. Okay, so very, very carefully, so that we don't slip with our probe, because we don't want to short anything out on these pads here. Let's probe H, which is this one here. So you see here we have on the scope screen, we do have an input. So we do have a square wave input for H, high side input. We should also have a square wave on L, which is the low side input, which we do. So we have all of our required drive waves. So the faulty component was most likely the IR2113S that was in this board previously. Great. Great. Drinking beer and learning from you. Cheers. Awesome. Good to hear. TNT Mackerel. Sorry, TNT Mackerel. TNT Marcel. Can you imagine TNT Mackerel? You're just like, you're fishing in the lake and you bite a mackerel bites and you start wheeling it in and all of a sudden, boom! TNT! That's not going to be fun for anybody. TNT Mackerel. Solder station you use. Peter says solder station you use. AOUA. It is an AOUA. It is a 2738A. I'm waiting for these rail voltages to disappear enough that I can sort this thing out. Wow, we still have 38 volts on the high side. So this amplifier is meant to have pull-down resistors, yeah, you see? So the low voltage rail has been slowly sinking down to 2 volts. The high side is still stuck at 36 volts, so it seems that the pull-down resistor for the high side capacitor seems to have failed. So I'm going to need to manually pull that down before I touch my soldering iron or my hot air gun anywhere near this board. Otherwise we could see sparks flying. Unless you're a fish, and then it's like some bad acid trip. The plows finally went down the road, boys. Awesome. Good stuff, Jason. I'm glad that you can finally get out your drive. Right, I need a 47 ohm resistor or something to get rid of that rail voltage that's still there. What have I got in here? Here we go. I've got 3 6Ks in parallel. That'll do. See the voltage there slowly sinking down, 15, 14, 13, 12, 11, 10, etc. with this 2K capacitor. Sam, what brought this down? Good question. Not sure. The whole amp was down. I have my inklings though. I have my inklings that it could have been something to do with the driver chip that's on this amplifier. It's not really the most suitable driver chip for this amplifier, so I think it probably overheated. It's quite a low current driver chip. What are those aluminium DOMI loads you're using to measure your amp? These are just regular static loads. They're great big resistors, so they're great big 4 ohm 1000 watt resistors. I got them from eBay, from China, in fact. Preheat the board again, get it nicely warmed up so this goes on nicely. Chris says, shitty amp brand. Yes, my friend. Sup? This is a shitty amplifier, this Power Acoustic. What's your favourite amps for a service? Good question. It depends what mood I'm in. If I'm in a good troubleshooting mood, then I like a challenge. I like an amplifier that's got quite a lot wrong with it, so that I actually engage my brain a bit, and you know, we can work hard for a repair, and it's more satisfying. But the easiest amplifiers are also my favourite because they're nice and easy, and I can get them done quickly and work through them. So possibly something like Bass Face DB 1.3 SPL Dynamics D1500 or something along those lines. Nice and easy repair, very basic circuit, very basic repair procedure. Hello Vladimir, thank you for joining in on the stream. Is it possible to repair an amplifier without an oscilloscope, says Aaron? No. Well, I mean, possibly if you get lucky, but not really. I really do not recommend anyone try amplifier repair without an oscilloscope. It's, you're really kind of going in blind there. There we go. Looks almost factory. You would never know. You would never know. Apart from all the nasty pulled vias from the for the attempted customer repair. The customer attempted to repair this one before it got to me and pulled all the vias out of the board. So just to make sure that all of the legs soldered down nicely, just take our probe here and just apply some pressure to each of the pins, and they shouldn't move. They shouldn't bend away from the pads. If they do, they're not soldered properly. It's just a check that I like to do, because sometimes these pads have very high thermal. Yeah, you see here, there's a pin that's not soldered properly. Ah, that's annoying. So we're just going to get our soldering iron and just run some solder on a couple of these. Well, there's one that didn't solder that well, and the one that didn't solder that well looks like it is. I think the one that didn't solder that well is actually the ground, which has the highest thermal mass. So that pad obviously didn't melt it quite enough. So we're just going to very easy take our nice pointy tip iron, and we're just going to manually solder that one on. I fixed today my first class AB thanks to you. Diode died, a couple of IRFZ44s, so that was the TL494. Really? The TL494 very rarely dies. How did you work out that the TL494 died? What did you do to check that? Z44, yeah, that's good. What did you replace the Z44 with? Out of interest, buddy. Gravis, how do you go about charging customers for amplifier repair? Hourly or by parts? Partly by time. There's no real set hourly rate because yeah, I don't know. I find that more complicated to work out. I base the cost of the amplifier repair on its complexity, how long it's taken me, how much the parts were, how much they cost, and it's you know, there's no sort of like I don't stick to a kind of strict regime as to how much the amplifier I charge them. It really kind of just depends on the complexity of the repair and what the parts all cost. Because sometimes, for example, right, if I have a big amplifier that is a complex repair, but I know how to do it and I've done it before with a similar issue, then it might take me less time to do than a small 4-channel Class AB that has some crazy ass issues that's got me here scratching my head for ages. So the small Class AB 4-channel might take me longer to repair, but I will charge the customer less for that because it's not the amp's fault it's taking it longer to repair. It's just there's more complex. It's like the issue was harder for me to find, or maybe I haven't dealt with that exact issue before. So I won't charge the customer more for that Class AB than I would charge them for a 5K that I know where the fault is. Even if the fault is complex, if the 5K had dead power supply drive circuit, dead power supply PWM chip, and output section had dead drivers, dead Zener diodes, dead pull-down resistors, and dead voltage regulation circuit, and small green inductors. I know all those things. I know to look for them, and they're easy to find, and I'll repair them, you know, in not too long a time. But if the 4-channel is a flipping headache and takes me hours and hours to work out what's wrong with it, then it'll take longer. But I won't charge them more for that because, you know, who wants to pay more for a repair than the amplifier's worth? My solder station is an AOUA 2738A. I don't necessarily recommend that you buy it though, because it's not that great. Like, save up for a Hacko or something. It's just what I happened to have when I started amplifier repair a year ago, and it still works, so why replace it? Right. So we replaced the 2010, the 2010S chip, and that seems to be the only problem here. So I should be able to power this board up now, and the damn thing should work. Let's see. Let's see. Huh. Wait. No, it doesn't work still. Still doesn't work. Okay, there's something else going on here then. There's something else going on here that's stopping this thing from working. It's trying to work. It's trying to work, but it's not. I'm gonna try 12 volts. Oh, actually, let me just pull our 40 hertz out of the amplifier. This thing should come on regardless. Right. So the drive chip, although it looked like it was the issue, because we do have the high input going into the chip and the low input going into the chip, that's not the thing that is preventing it from working. Okay. Interesting. Yes, yes, I had the third error. I have checked this with the 12 volt supply, and it does exactly the same thing. So that's not the issue here. The issue is not the 9.8 volts input. I've checked that already. Okay, so we're just pulling our rails down to ground because the pull-down resistors for the high side seem to not be functioning properly. Right, so new driver IC doesn't help. It does not help. I'm going to check these inductors because this inductor is wobbly as hell. So I'm just going to check that they're both connected to the board. I'm also going to check their inductance. We can do that with our ESR meter. So they're both connected to the board. So let's get our tester here and see what the inductance is of these inductors. Make sure that there's not a short. Oh, for goodness sake, these test leads are absolutely crap that come with this. Okay, so our first inductor has an inductance of, oh wow, what's that, 0.4 millihenries? .4 millihenries. Okay. So what's our second one? It's a bit lower than I usually see. And the second one's the same, 0.4 millihenries. And it will its pass frequency is about 1,700 kilohertz. Wow, that's really high. No, it's not. That's not our pass frequency. I think this test is just getting very confused. It's all over the place with the frequency. But we can read our millihenries there. We've got 0.4 millihenries and a 0.2 ohm resistance on the coil. So the inductors seem to be okay and not shorted. Okay, so it's not the inductors. So what else could be preventing this thing from working then? We've taken the IR 2010 chip off, or the original one that was in there, and taking the chip off shows us that we do have our drive waves, our high side and our low side logic drive waves on the chip. The next thing we need to look at though is the chip receiving all of the correct supply voltages in order to work? So let's power up again and let's consult the schematic and let's see the data sheet for this, and let's see whether we do have all the correct voltages for this chip. Okay, so pin 1 is low output, which obviously we don't have. Pin 2 is VB. VB is, oh sorry, pin 2 is COM. Pin 2 is COM. So COM is going to be ground. Pin 3 is VCC, which is the power to this chip, which we have 40.9 volts, which is about 10 volts referenced to the ground, which is 50. So this chip is seeing plus 10 volts of VCC, which is, I think, probably enough. That's fine. Pin 4 is pin 4 is nothing. Pin 5 is nothing. Pin 6 is VS, which is high side floating supply, which is 0 volts because that's what the high side should be driven around, 0 volts. VB is oh no, sorry, VS is high side floating supply return, which is nothing. VB is high side floating supply, which is 0 volts, which is correct. HO, which is number 8, is high side output, which is again nothing because the thing is not working. Pin 9 is nothing. Pin 10 is nothing. Pin 11 is VDD. Now VDD is on the thing here, is logic supply. So this is our general logic supply, which we haven't got anything of. So if I plug our 40 hertz back into this board, we should see something on the logic supply. So if we now have a look at the logic supply, which is VDD, pin 11, do we have anything? Okay, so we don't have any logic supply. With that might not be part of this. I don't think VDD. So pin 12 is high input. So we saw a square wave before on high input. There's no square wave now. We saw a square wave on high input when the chip was removed, and you can see the state of the square wave is looking very bad. It's all over the place. You see that? That's I don't know if you can see that. I might need to put my scope on the right. But yeah, that's very bad. That's not looking good at all. SD, next pin along, is logic input for shutdown. Well, that's not, the thing's not in shutdown, so that's fine. Next input is the low side drive, which is also looking very bad. And then the last pin here is VSS, and VSS is logic ground, which is fine. So there's nothing wrong with any of the supply voltages for this chip. There's nothing wrong with the supply voltages for this chip. Let's see what's going on in the live chat. What kind of glue are you using for the inductors and transformers? I'm using Digital Designs CA glue that you get when you recone a Digital Design subwoofer. It's very, very strong. When repairing amplifiers, have they blown up while repairing? A couple of times. In one of my live streams earlier on in the week, we had an exploding 20N50 FET on a 10,000 watt RMS amplifier. We also had an exploding capacitor, but nothing too bad. Sam versus the bad motherfucker. Yeah, man, this is turning into a bit of a headache. So tar amps are reliable as American cars. Huh. Okay. So all the supply voltages at the 2010 are fine. There's nothing wrong with the supply voltages there. So the next thing I'm going to be doing is I'm going to take our multimeter. I'm going to be looking at some diode setting readings and some resistances of all the resistors and capacitors around that area to see if we can find anything that's dead. But before I do that, this amplifier needs to be discharged because it still has the high voltage rail sitting on the capacitors because the pull-down resistors aren't working. So let's go ahead and discharge these capacitors. Okay, that should be discharged enough. Still got 6 volts sitting on there. There we go, slowly going down. The amp is rated at 5,000. 5,000 peak. I think this will probably do about 1,800 watts RMS once it's fixed. Okay. So let's take our multimeter and start probing some things around the board. So first we're going to check the gate resistors. The gate resistors on this amp should all be 20... Oh wow, hang on a minute. 220 ohms? Wow, it's quite a high gate resistor. 221. That is 220, isn't it? Yes. That's incredibly high gate resistance. Okay, interesting. So let's make sure all our gate resistors are okay. They're probably fine. $220. Yep. Okay, so gate resistors are fine. Let's check our pull down resistor, and our pull down resistor is just here. So this is a 103, so this is a 10,000 ohm resistor. So we need to make sure that we have 10,000 ohms on that resistor, which we do. We have 10,000 ohms on the multimeter there for that resistor. Yep. Okay, so resistors are fine. Let's check these Zener diodes now next to the next to here. I'm also just going to check the pull down resistor for the low side, because I didn't check that one there. So low side pull down resistor should also be 10k. Yep, 10k. So let's check these Zener diodes. They're all going to be fine because we will read 220 along the gates. That's going to be fine. So we've got a couple of 33 ohm resistors over this side. Let's see if they are 33 ohms. 33 or 34. Yep, 33, 34. That's fine. D8 is a diode, so we should see infinite reading one way with the probes, and we should see a value about 470 the other way, which we do, and the other way we might see infinite or higher. Yes, we see infinite. So a diode should generally see infinite one way and a diode reading the other way. $70, 10. I'm wondering if the gate resistors are too high. Because I've never seen gate resistors quite that high before, and I can't see anything else immediately that would be wrong with this amplifier. I'm going to power up again. I'm going to play 44, 45 hertz through it. I'm going to probe some of the other things around some of the chips and see if anything gives me any hints. So that's our janky ass high side drive, not looking very nice. It's offset by about 12 volts. Which is interesting. What's on our speaker outputs? We have minus 3 volts on our speaker outputs. Okay. So they're not getting hot when we're testing this, which is good, which means that I can continue to test like this without any problems. So this chip here, this chip is responsible for sending all of the drive waves to the 2010S. So this amplifier actually works in a very similar way to the Banda amplifiers. This chip is working in a very similar way to the Banda amplifiers and the tar amps. So I wonder whether this chip is dead as well. Okay, the next thing I'm going to do, just as a kind of, I'm going to attack this amplifier with ideas. We're going to replace this chip here. Where are we? We're going to replace this chip here, which is sending the drive waves to the 2010. We're going to replace the LM311, and we're going to replace this with a 072C. We're also going to replace this very small transistor here, which has got something to do with feeding the drive to the correct chips, just to see if that sorts anything out. Now that small SOT23 part says, I think that says 2L on it. Yeah, that says 2L on it. So we'll find out what that is in a moment by looking at Google. Old power acoustics were very nice, yeah. 2L is gone. LM311 is gone. And our 4580 is gone. Okay. So let's replace those with 027C, 211, Off topic, but have you ever had any experience with Pioneer's Apple CarPlay units? I have not, no, sorry buddy. I have never owned anything by Apple. Actually, the last thing that I owned by Apple was a very early on Apple iPod Nano. I'm not a fan of Apple products. So I've never needed Apple CarPlay. Dog says, bro, you stole your mate's girl. Nah, man. Nah, she was a nightmare in reality. She got pregnant and she now has a kid. And I never dated that girl. Have you ever worked on these sundown amps yet? Yeah, loads of sundown amps. Okay. And let's find out what that little 2L was. Little 2L transistor. 2L transistor. What was that we removed? So it's a PNP transistor, and it looks like a 4403 or a 5401. 5401 seems to be the most common one, so I'm gonna go with that one. Let's have a look at the data sheet for that one. So this is a negative. This is a PNP. This is a 150 volt. And 600 milliamp. Okay, so we want something that's around about the same values. So let's see. I have a 2D, which is an A92 transistor. Will that one fit the bill? I think it's 2SA. 2SA. That's minus 300 and 500 milliamps. So that would also work. That would work fine. But do I have one that's better suited? That's a 2D. That's a PNP. Let's have a look at the 2X SMD transistor. See if that's any better. Okay, this isn't high enough voltage. These ones aren't high enough voltage. So we're going to go with a 2D. We're going to go with the 2D because that's what I have here. So we're going to go with the 2D. Don't tell me I've run out of 2Ds. Would it be better to get a 3-in-1 station or just a solo solar station? If it's good, read some reviews. If it's good, the 3-in-1 is obviously nice and handy. Seem to have run out of 2Ds, which are very common. So I'm surprised that I've run out of those. So I might have to steal a 2D off of another board. What should a good power supply voltage and amps go up to? What for? For testing amplifiers on the bench, or for actually doing a power bench test? So just for firing them up and repairing on, or for actually doing a power bench test to see how much power it does? Well, damn, seems to be out of 2Ds, so I'm going to have to steal one from a driver board. That'll do. Powering things up and powering things up like amps and more. For car amplifiers, you don't want anything more than about 4 or 5 amps. 4 or 5 amps, and obviously anywhere between 10 and 12 volts is ideal. Anything more than that, and you don't get enough warning if anything is wrong with the amplifier before it smokes and you damage things. So you want a small power supply when you're powering things up on the bench for amplifier repair. For actually powering things to run them and use them, obviously the more current the better. See, this one in 3-in-1 station online, but only goes up to 15 volts and 2 amps. That's more than enough. Well, the 2 amps is a little bit low, but that you should be able to power up car amplifiers on the bench for just running them, idling them on the bench with that. But let's see if changing those parts has made any difference to this amplifier then. I bet it hasn't. I bet it still doesn't really work. Nope. Okay, so same issue. Same goddamn issue. Same problem. Same problem. So it wasn't those chips. So the last chip that I'm going to try and replace is this big one here. If that doesn't fix it, then yeah, we'll try some other things. Right, so what exactly is this then? This is a... Can I read you? 4BC... I can't get the line up. It's 4BCSEL. I think I have some spares of those on some bandit amplifiers that we've been looking at. So, this is a bandit amplifier. I think we have a spare one of those. Is that a solo rework station there? This station that I use is it's an AOUA, and it is a soldering iron plus hot air gun. Check page 5 thread at DIY, BAMF5500, no output. Okay, I'll check that out. I shall see what it says. We have no Class D switch here. Can anybody just to save me while I'm soldering this, can anybody just do me a quick TLDR on that page? So I can understand exactly what it is that they're looking at, because it could just be an inductor that's fallen off, which in our case is not the problem, but it would be a common problem because these inductors look like shit. Yeah, if anyone can do me a quick TLDR on that that BAMF no output page, just give me let me know roughly what it is that they're talking about, and I can see whether it's worth me looking at it or not. Okay, let's very quickly see then, has that made a difference? If it hasn't, I'm going to go and have some dinner and come and tackle this a little bit later. Okay, no, now we have nothing at all. So that's actually made it worse. Okay, right. I'm going to go and have some food, and we are going to tackle this after I have eaten and see what the bloody hell is going on with this. Thank you very much for tuning in, and if you're interested to see if I get anywhere with this, then stick around for the next live stream notification, and I'll see you all in a short while.